Hello again, and welcome back to another episode of Adding Game Sounds, where today we're going to be adding sounds, or all the sounds that are related to these things here, these big boxes that we're going to be pushing around in a level and using as platforms. Okay, so let's crack on with what we're doing today. So let's quickly start up our scene. And let's quickly demonstrate what I've set up. So for these boxes, there's two events I've added. The first one is basically a pushing sound. So if I quickly push this box around, you can hear it sort of scraping against the ground like that, and it stops and starts whenever you start playing it. But then if I push the box all the way off of this edge here, we get the sound of it falling, basically, just like our player does whenever we jump in the air. So the first event I've set up here is called Pushable, and the way it works is that it uses free audio files that come with the game kit. In fact, if I quickly go Assets, Interactables, I'll quickly play those for you. So there's a start sound. If I quickly play that, the sound of the box being pushed and started. The second one is a loop. So it's the same thing, but that'll just keep looping and looping. So no matter how long we're pushing the box, we'll constantly hear a sound for it. And then there's an end sound. And that plays, obviously, when we've stopped pushing the box. Cool, so I wanted to, obviously I wanted to implement all of these sounds into it, but I wanted to have them all into one event. I didn't want to have to make a separate event for a parameter, a separate event for the end file. I didn't want to have to use a parameter to trigger off the end file or anything like that. I wanted to do it as sort of neatly as I could, coding and implementation-wise. Annoyingly, there isn't a way, as far as I'm aware, within FMOD to trigger any sounds when an event is told to stop. Obviously, we could do that in C#, but in FMOD, it was a little bit tricky to work around. However, I think I've come up with a nice little solution. And as you can see, it's using FMOD's sustain points. So yeah, let's talk about how this works. As you can see, I've got 3 tracks here, one for the start file, one for the loop, and one for the end file. These first 2 tracks, I've actually ticked a little option you get if you click on any instrument in FMOD. I've made them asynchronized. So if you set an instrument to play asynchronously, what it basically means is if the cursor of the timeline in your event comes into contact with your instrument, it will still play, but it will play independently from the cursor. In fact, if I quickly start playing it, let's quickly turn the volume down so we don't hear it. You can see that there's actually its own cursor that's been created whilst the timeline cursor is sitting on top of it. So long as the cursor of the timeline is touching this box, no matter how big or small we make it, it will trigger the audio within it. So whilst the cursor is touching the box, it will continue to play the audio file within it, not necessarily at the exact time as the timeline, but it will continue to play nonetheless. However, if the cursor was to move away from that box, you can see that the cursor is still playing. Once it reaches the end there, it will then stop. So it finishes the audio file and then stops. However, if you want it to stop when the timeline cursor completely stops touching the instrument box, all you have to do is select this cut option here, and it will do just that. So if I play it again and the cursor leaves, you can see that the audio file was told to stop. So that's basically what I did for the start and the loop audio files. I put them into single instruments in FMOD. I made them both asynchronous and I made them both cut. So yeah, the idea is that whilst the cursor is touching these, they'll play. The first one won't loop, obviously, we just want that to play once, but the second one will. This will loop continuously whilst the cursor is touching it. The way I'm able to keep the cursor in place like this is by using what's called a sustain point, which you can create by right-clicking up here and then clicking Add Sustain Point. Now, we've talked about timeline sustain points before. The idea is that they will hold the cursor in place whilst the cursor touches the sustain point. So if I were to move it over a little and hit play, you can see the cursor moved until it came into contact with the sustain point and then stopped. It's not until we tell the cursor to key off by pressing this button here, or on our keyboard pressing the comma button, that the cursor will then move away from the sustain point and continue to play. So as we can see, I've told the cursor to sit on top of this sustain point here, basically right at the beginning of the event. This means that both the start audio file and the loop audio file will play, but the cursor won't go anywhere. The reason why I don't want it to go anywhere is because I don't want to trigger the end audio file just yet. If I click on that, you can see that I've not made it asynchronous, meaning that for it to play, the cursor actually has to pass along the audio file itself. If it doesn't move, then the audio file won't play. So what I'm basically going to do is use this sustain point to trigger the end audio file. Whenever we implement a sustain point, we can tell the cursor to move off by pressing the key off button here, or by pressing the comma button on our keyboard, like that. And then that will tell the file to play. So the idea is that within C Sharp, we're going to tell this event to play, right? We're going to tell it to play when the box starts moving. When the box stops moving, that's when we're going to key off the sustain point and tell it to play the last audio file. And there we go. That's essentially everything I did for this event. Like I said, it's a nice and simple one. If I quickly go to our master track, the only other little edit I made is that I increased the minimum distance just so that the event didn't sound like it was coming from a small little point in space. Obviously, it's coming from a big crate. It's going to sound fairly big. In fact, I might even just I'm going to bump it up a little bit because I tested it earlier. It still sounded quite small. The idea is that I just wanted to sound a little bit wider when the player is near it. Okay, so the other event I've created is called box falling, and essentially this is set up the same way as our player falling sound or element falling event we created a couple of episodes ago. The idea is that we've got this audio file that loops. It's just white noise, basically. And it will only play if this velocity parameter here is less than 0. Okay, less than 5, rather, because we've automated it. So if this parameter, let's play it, actually. If this parameter is less than 5, we'll start to hear it, okay? If we quickly go over to velocity, as you can see, the volume is automated so that the lower the parameter gets, the louder in volume it also gets. But as you can see, I've also automated the pitch of this instrument here, which is something I didn't do on the last one, and for the player I could have done, I suppose. The reason why I've done it here is because I just wanted to separate it a little bit from the element falling sound. Because obviously this is, if we go back to Unity, actually, let's have a quick look. If we look at them side by side, the crate looks like it'd be a lot heavier than the player character. So I kind of wanted to, even if only slightly, bring that out in the audio. So I've added this little pitch automation so that as it falls, it kind of picks up speed and sounds like the air rushing past it is, moving faster as well. If I go back to the timeline, click on the first track, I've also done some EQ as well. So I've taken out some of the middle, some of the high end, and added some low end. So it just sounds a little bit more heavier than the player falling. And that's basically it on the FMOD side. So I think it's time we jump over to Unity and learn how we set this all up in code. Okay, so let's start by talking about how we can get the sound of the crate being pushed to play and stop first. The way I did it is by using this script here, the pushable script, which is one that already comes with the not 3D, 2D game kit. And as you can see, it's already kind of being used mostly to play audio. But obviously, this is Unity audio, which we're not interested in. What I am going to do is utilize some of the functions that was created for this script in order to play our event. If we jump into the script here, the first thing I did in the top of the class is create some event instances. I created one for the sound of us pushing the crate, one for the sound of it falling, and I've also created a playback state, which I'll be talking about in a little bit. Then in the await function, I took those event instances and I basically linked them to our event. So the pushable event is linked to the push sound instance, and the falling event is linked to the fall sound event instance. So if we come down to about line 100, probably actually because I've edited this script already, it'll probably be about line 90 for you guys, maybe even more, maybe right there. So if we come down to about line 100, actually probably around line 80 for you guys because I've edited this script a little bit. But if we scroll down the script, we'll basically find a function called start pushing, end pushing, and one called move. Now these functions are all being used to basically trigger audio, and that was their purpose before we implemented FMOD. So we're just going to reuse them basically. We're going to use them to trigger our audio. As you can see in the start function, I've set the 3D attributes of our push event, the push sound event, by using the attach instance to game object command, and I've just linked it to the transform of this object and said get component rigid body. So on every one of these pushable crates, we're just going to check the transform and rigid body of it if there is one. Oh, there is one. Okay, good. Just so we know where in the game the object is located so we can play the sound at that point. Nice and easy stuff, which we've done before. Once we've done that, I've told the event to start playing. So if we go back to FMOD, let's go back to our event quickly. We'll start to hear that. Let's go back to the script. Then we've got the end pushing event, which as you can see here, I've used a line of code called trigger Q. Now, if I go back to FMOD, the same way I was basically pressing this button here, or pressing the comma button on my keyboard, that's what that line of code does. It essentially cues off any sustain points that the cursor, oh, whoops, wrong tab, that the cursor has run into. So obviously we know that our cursor is just straight away going to hit the sustain point. So we can essentially call that trigger Q command at any time, which is nice because essentially the player could stop pushing that box at any time. It could start and then within a fraction of a second stop. So it's good that we were able to do that, instantly. Now, the way these functions are called is actually kind of interesting. Even though they're created within the pushable script, which is attached to every one of the pushable boxes within our game, the function itself is not being told to start or do anything in this script. It's actually being told to trigger within the player character script. As you can see here, they've created other functions, one called start pushing and another called stop pushing, which will basically find an instance of those cubes within this game, probably the one that Ellen's nearest to, I suppose, the one that's, if we remember from last time, I think in the last episode, we talked about how, if I quickly zoom into one of these, let's go back to the one Ellen's near. We talked about how either side of each cube there is 2 trigger boxes. So I assume what's happening in that new script, the player character script, is that it detects when Ellen has entered one of those trigger boxes, and will then say, okay, if you're pushing one of those boxes, we want you to start the function that's within the script attached to that box. So yeah, this start pushing function is basically telling the start pushing function within the pushable script to play, basically. The same thing is happening with the stop pushing function. It's telling the end pushing function within the pushable script to play, or to stop rather, I suppose. So if we remember from last time, the player character script, let's go back to Unity, is attached to Ellen herself, which makes sense. If we're checking for trigger boxes, we're going to want that script attached to Ellen. Is it this one here? Yeah, there we go. So it's this one here, the player character script. However, if we go back to the player character script, these 2 functions are also not being told to start within this script. They're actually being told to start within the pushing SMB script. So in the on SL state post enter function, wow, that's a mouthful, the start pushing function from within the player character script is being told to start, which in turn tells the start pushing, where is it? There we go, start pushing function within the pushable script to start. And I think the same thing is going on. Oh, okay, so it's not going on for the stop pushing function. It does have the move pushable function, which also links up to the player character script and then the pushable script. But the reason why I think it's not telling it to stop is because of the way it works, basically. So this script here, you may have noticed, isn't using mono behavior, which is the base class that all of our other classes within Unity that we've been creating so far inherit from. And it allows us to use functions like on void start and void update and all that sort of stuff. The reason why it's not is because it's actually being used within another section of Unity. If we go to the Animator tab over here, let's actually make some room. We've got all of these crazy lines and boxes that we've never seen before and don't know how to use. So let's quickly talk. We're just going to get a rough idea for how this works so we can understand how this crazy train of functions is actually working. So what we're currently looking at here is the Animator Controller for Ellen, our player character. Each one of these little boxes basically can trigger an animation or, multiple animations, depending on what's going on within the game. We've also got loads of parameters here that check for certain behaviors. So, for example, we can check to see if the player is grounded, if it's pushing anything, which is what the one we're going to be after, if the player's been hurt, dead, and so on. Now, if I click on this box here that says pushing, this is basically what will play our Ellen animation of her pushing. Let's actually quickly demonstrate how these animations look like. If we double click on one like I've done here, open up the little preview window, let's drag a model in so we can see what it does. So we want to go in our assets folder, we want to go 2D game kit, we want to go to prefabs, we want to go to Ellen or characters or something along those lines. Ellen, there we go. And then no, that's not it. Oh, that's VFX, my mistake. Let's go prefabs again. Ellen, there we go. So let's drag that in there. And there we go. If we click play, we can now see what the animation of her pushing looks like. The idea is that these boxes kind of trigger all these individual animations based on these parameters here. You can actually create scripts that can use these parameters, and then we can say, for example, the grounded, as you can see, is a Boolean variable. It's either true or false. So we could tell that to be true or false, and depending on whether it's true or false, it will tell some of these animations to play or start. And all of these lines connecting them are kind of like transitions. So if, for example, the player can go from a jump animation to a running animation or from a running to a crouch, you have to kind of link them up together to, create these possibilities and these kind of transitions into each animation. So if we click on the pushing animation here, we've got a pushing SMB script, which is the one I just showed you. If I go back to monodevelop, it's this one here. That's what that script looks like. And from my understanding, this script is triggered whenever one of these other animations is transitioned into pushing. So, for example, the locomotion animation, which I think holds running, walking, and standing still, will actually transition into our pushing. We can almost here we go. So under transitions, we can actually see where it's been set up. So there's a setting that sends the locomotion animation to pushing, and if we scroll down, we can actually see the condition that has to be met. So the pushing parameter has to be set to true, which I'm assuming is set to true when the player enters one of those trigger boxes. It will then tell the parameter to change. It will also probably, change the physics of the box so it actually moves with Ellen. And then from that, not quite, if I'm honest, I'm not sure how. I need to do more research onto how the animations work, but it will tell these functions to trigger in some way, shape, or form. From there, it will then tell these functions to trigger, and then from there, it will tell these functions to trigger, which will tell our audio to play. Oh, that was long, but we got there. I hope that didn't confuse you too much. It's a weird system, which, like I said, I don't know the ins and outs of, but we'll have a few videos to some other tutorials on YouTube, which I found quite helpful. Okay, so next is the falling sound. Like I said earlier, the falling event kind of works a similar way to how it worked for the character, the Ellen, whenever she falls. But I've set it up with the script slightly differently. The reason why is because there's actually a few variables and systems already created in this script, which we can utilize for this. So if you remember back to the episode where we looked at Ellen falling, one of the things let's go back to the scene. One of the things we had to make sure would happen is that the sound of Ellen falling would start when she was not touching the ground, when she was falling past a certain velocity or certain speed, and if she ever entered a watery area or the acid, we had to be able to tell our sound to stop playing. And we're going to do the same thing with our bogs, but we're going to do them slightly differently. So like I said earlier, at the top of the script, we create the event instance for it. We also create a playback state. And then the awake function, so as soon as the game starts, we're going to store an instance inside that variable of the event we created in FMOD. Next, we want to come down to the fixed update function, and this is essentially where everything is going to be kind of looked after and managed for this event. As you can see, the first thing we're doing is getting the playback state of the falling sound event instance and setting it to the PB state variable we created earlier. So now we'll be able to check by calling this playback state whether our event is playing, whether or not it's stopped, whether or not it's sustained. Well, actually, we might need to do that. But yeah, those are some of the things we can do, which we've talked about before in other episodes. Then underneath that, we've got a few lines that were that were already in the script. The gist of them is these are kind of how the script measures the cube's velocity. We can kind of see here that it's using basically the rigid body of the cube. So if we go back to Unity, let's go on to the pushable box we're standing next to. We can see it's got a rigid body 2D attached to it. And we can we can use the rigid body to check a game object's velocity simply by writing rigid body 2D in this case, dot velocity, and then within that, store it within a vector2 or a vector3 if we were doing this within a 3D game kit. And that's essentially all they've done here. They've created a vector variable and stored the velocity vector, which is inherited from that rigid body component within it. And we're actually going to be using that in a little bit. Then there's some other stuff that we don't really care about. Some more velocity stuff. It's just setting the X velocity to 0 so that it doesn't start moving left or right. It's also checking to see if the object is grounded by applying a function. If we scroll down, this is the function here. This is basically, like I said, checking to see if the cube is touching the ground. We don't need to look into that too much. All we really need to know is that this variable here, m_grounded, is a boolean, and whenever that's true, we know that the cube is touching the ground, and if it's false, it's not, which we're going to be using in a little bit. So let's go back up to the update function. So under our call to check whether or not the player is grounded, we have a for loop. Now, a for loop is something we've not really talked about on this channel and can get a little bit confusing if you don't know, if you've never seen one before. But I'll explain how they work. First, I need to explain how something called an array actually works. As you can see in the condition of this for loop, we're using something called m_water colliders. Now this is actually an array which is set in the awake function just up here, just here at the bottom. So let's quickly talk about what's going on here. So as you can see on line 60 here, there is a new variable being created called water areas. Now water areas is a reference variable. We know that because we are using the water area class from our water area script as the data type. And as you can see, we are setting the instance that we're going to store within this variable to any object that contains the water area class or script attached to it. Notice, however, there is two kind of squared brackets in between the data type and the name of the variable. And whenever you see this, this is basically telling us that this variable is an array. Now think of an array as like a list. There is actually something in C# and Unity called a list, but for now think of an array as a list. It's a list of whatever data type you're after. So in our case, this water areas variable is a list of water area components. Essentially, any game object that has the water area component attached to it will be stored within this variable. So if we jump back into Unity, we know for a fact, if I quickly, hang on, let's quickly make the scene to have a little bit bigger. There's two game objects with the water area script attached to it. There's this one here at the bottom. If I scroll up, there's this one here at the top, okay? So inside this variable, we now have two instances or two references to do different objects. So next, on line 61, we have another new variable called m_water colliders. Now, if we scroll up to the top of our script, we can see that this variable has already been set. It's of the type collider2D, and it's also an array. So we can also store multiple 2D colliders or references to 2D colliders in this variable. And whenever you see an array followed by the equals operator, the word new, its data type, and then two more squared brackets with information in them, that is basically the way we set the size, or the length is another word for it, of the array. Arrays can have any size you like, but they have to be set by doing this, and you write it inside the squared brackets. What's happening here by writing water areas.length is that we're actually setting the size of our m_water colliders array to match the amount of water areas we have in this variable, which we know is 2. So the size of this array is 2. Then underneath this, we have a for loop. So let's talk about how they work. Now, for loops are broken up into 3 parts, as you can see here. This is the first part, this is the second part, and this is the third part, and all of which are separated by semicolons. In the first section, we have to create a new integer variable, and this integer variable is to be specifically used inside the for loop. It's quite common to see an integer variable be created with the name I, so that's what they've done here, and you can also set this variable to any value you like. So they've started this variable off as 0. Next section is the condition. It works exactly the same way as an if statement would, essentially. We give it a condition, and then whether or not that condition is met, we run more lines of code. The difference is that the condition is usually based off the integer variable we created in the first section. So as you can see here, the condition is we want to check to see if the amount of water areas is greater than I, which we know is 0. And finally, the third section is the increment section. Basically, what happens here is that we change the value of I so that when this is run again, we don't get a infinite loop, essentially. The reason why this is important is because we can run for loops multiple times, unlike an if statement. This all happens in the same frame as well, so as long as this condition is still true, we'll keep running this for loop in the same frame multiple times until this condition is not true anymore. At the end of each loop, the increment section works, and it changes the value of the integer we created in the first section. By doing that, it forces this condition to eventually not be true, so it limits the amount of times we can actually run this for loop. Now, we already know that water areas.length basically equals 2. This means whenever the awake function is called, the for loop will be run. So the first time, I will equal 0, and water areas.length will equal 2. So therefore, this section here is run. Then in the same frame, the value of I is increased by 1, and the for loop is run again. This time I now equals 1, and water areas.length still equals 2. So this is run again. Then the value of I is increased one more time. So now that I is equal to 2 and water areas is equal to 2, this section here won't be run because now I is not less than 2. So to sum up, basically this section here is now being run twice within the same frame. As you can see in this section here, we are also using the value of I. What's happening here is by using the m_water colliders variable, we're actually getting the component of each 2D collider attached to each object that has the water areas component attached to it. But to differentiate which collider is attached to which water area game object, we're using the I integer. So the first time the for loop is run, I will equal 0. This means that we'll be getting the first game object that has the water area component attached to it, and we'll be getting the collider 2D component from that object and attaching it to the first value in the m_water colliders array. Then the second time the for loop is run, I will now equal 1, and this means we'll be getting the second component to attach to the second game object. So basically with arrays, the first value is always considered 0, and then the second 1, and so on and so forth. Hopefully I've explained that well enough, and hopefully that wasn't too confusing. But now we understand all of that, let's scroll back down to the fixed update function and see how we can use this for our audio. So in this for loop, we're creating a new integer called I and starting it at the value of 0, just like we did the first time. This time the condition is to check the value of I is less than m_water colliders.length. So because we know that there were two game objects with the water areas component, and we took 2D colliders from those two objects, we know that this will also equal 2. And then finally, we're also incrementing I by a value of 1. So each time the for loop is run, we're going to increase the value of I by 1. So let's have a look at what happens the first time this for loop is run. So in the first if statement here, we're looking to see if the rigid body of the box that's falling is ever touching one of those colliders. Now, because I equals 0, we know it's going to be the first collider in that array. So if we jump back into Unity, it doesn't really matter too much, but one of these game objects is basically the first in this array. So let's just say, for example, it's this one here at the bottom that it's decided to set as the first one in this array. It's going to then check to see if the cube or the pushable box is touching this water area or this collider. If it is, then all of this stuff inside the if statement is going to be run. Now this first line is basically freezing the object in the x-axis so it doesn't move left or right. It can still bob up and down, which creates a nice movement effect in the water, but it can't move left to right, which is good because that creates a stable platform for the player to jump on. Next, I've created my own if statement, and I'm using the playback state we created to check to see if the falling sound has ever stopped. If it hasn't stopped and it's still playing, then I want to tell it to stop, which is what I've done here. If it has already stopped, then this line here, stop, allow, fade out, won't be run. However, if the box is not touching the first water collider, then this else statement will be run instead. So because we know the box is now not touching a water area, we want to check to see if it's not grounded at all on any surface, and we also want to check how fast it's falling. So we're checking its velocity in the y-axis, and we're seeing if that is less than -3, because remember that means it's falling downwards at a fast speed. If both of these conditions are met, then we can set the parameter value velocity to match the velocity our box is falling at in the y-coordinate. If both of these conditions are met, then that's great. We can set the parameter value of our velocity parameter to match the velocity of the box falling in the y-axis, just like we did for our player. Then we want to check to see if the falling sound is playing. If it's not playing, then we basically want to tell it to play, which is what I've done here, as well as attach the instance to a game object so it gives it a 3D position within our game. However, if it is already playing, then this if statement won't be run, and this prevents us playing it over and over again every frame. Now, normally we would be done here, but remember, because this is all in a for loop, on the same frame that this is called, we have to run it again. This time, I is going to be incremented at the end of the first for loop to 1, so that we can use that in the second loop. So let's quickly run through it again. This time, we are checking to see if the rigid body of the cube is touching the water collider array value of 1. So this time, instead of this bottom one, we're checking to see if it's touching this one here. Again, if it is, we want to freeze it in the x-axis. We want to check to see if the falling sound has already stopped, and if it hasn't, we want to tell it to stop. If it's not touching that body of water, then we want to check to see if it is grounded or not, and if it's falling faster than -3. If both those are true, then we set the parameter again, we check to see if it's playing, and if it isn't, we tell it to play. And by doing this, we're basically able to check to see if our box is ever touching either of the two bodies of water without having to send variables and values between two other scripts. We come to the beginning of the for loop, we check to see if I is less than n_water_colliders.length, which we know is 2, so therefore it doesn't run again because it's now equals the same as it. Now hopefully that made sense. We've never talked about for loops or arrays on this channel before, and it can be a little bit of a tricky concept to grasp, especially if you're from an audio background like I'm sure you are, and you're not too familiar with the coding side of things. So please let me know in the comments if you understood that. Hopefully I explained it well. I am going to, as I always do with this stuff, throw some links. Actually, no, not links. I'm going to stick a title card in the top of this video, top right of this video if I can. Actually, I'll do both. I'll put links in the description and a title card at the top right for you to look at some more tutorials on arrays. Because once you get the hang of them, they are pretty simple to understand, and they can be really helpful, as you can see here. Awesome. But with that, I think we are done for this tutorial. So that was episode 8 now. Wow, we're getting through these of adding game sounds. Great, so as always, let me know what you thought, what you're looking forward to seeing next. I'm not really too sure where we'll go from here, but it'll probably be to do with adding some more sounds to stuff that isn't Ellen, just some stuff in the environment of some of these more busy levels like this one. And yeah, don't have anything really much to say after that. Let me know if you understood all that array stuff, and let me know if there's, like I said, anything else you want to see from this series. Yeah, and I'll see you in the next one. I've been Henry Scott. Thank you very much for watching.